Hi all. So far we were discussing about trigonometric Fourier series. And today we will discuss exponential Fourier series. The trigonometric Fourier series we have x of t equal to a0 plus sigma an cos n omega 0 t plus bn sin n omega 0 t. That is having the terms cos and cosines and sines. And we know that cos theta equal to e raised to j theta plus e raised to minus j theta by 2 and sin theta equal to e raised to j theta minus e raised to minus j theta by 2j. So substituting this for cos theta and this for sin. So x of t equal to a0 plus sigma n equal to 1 to infinity an into substituting this, that is cos n omega 0 t becomes e raised to jn omega 0 t plus e raised to minus jn omega 0 t divided by 2. Similarly, sin n omega 0 t becomes e raised to jn omega 0 t minus e raised to minus jn omega 0 t divided by 2j. And taking these terms together, an minus jbn into e raised to jn omega 0 t divided by 2 plus an plus jbn divided by 2 e raised to minus jn omega 0 t. Now let cn equal to half into an minus jbn and c minus n equal to half into an plus jbn and c0 equal to a0. And the equation becomes x of t equal to c0 plus sigma n equal to 1 to infinity cn e raised to jn omega 0 t plus sigma n equal to 1 to infinity c minus n e raised to minus jn omega 0 t. Now we want to get these terms alike. Therefore, we are changing these limits. You see, the limit in the third term is sigma n equal to 1 to infinity. So we are changing that limit, that is from n equal to minus infinity to minus 1. So that we can get the second term also e raised to j n omega 0 t. Here it is e raised to minus j n omega 0 t. So we are changing the limits. Then we can write here also e raised to j n omega 0 t. So we can have the equation x of t as sigma n equal to minus infinity to infinity. Here we have minus infinity to minus 1 and here we have n equal to 1 to infinity. So we can have x of t in the form sigma n equal to minus infinity to infinity cn e raised to j n omega 0 t, where cn equal to 1 by t integral t0 to t0 plus t x of t e raised to minus jn omega 0 t dt, and c minus n is 1 by t integral x of t e raised to jn omega 0 t dt. So we know that from this equation c0 is a0 and cn is half into an minus jbn, c minus n is half into an plus jbn. So this is for converting from trigonometric to exponential. Similarly, from exponential to trigonometric we have a0 equal to c0, an is cn plus c minus n and bn equal to j into cn minus c minus n. Now, what is a frequency spectrum? Hope you remember the term frequency spectrum. So that means in the last module also we have discussed in the case of Laplace. So in the case of frequency spectrum we have two spectrums, that is magnitude and phase. What is the magnitude spectra? That is the magnitude of Cn versus n or n omega 0. And the phase spectrum is angle of Cn, the phase of Cn versus n or n omega 0. So we can see this in detail in the problems. So we can start with an example. Find the exponential Fourier series and plot the magnitude and phase spectra of the following triangular waveform. So we have to find out the exponential Fourier series first and then the magnitude and phase spectra. So this is the given signal. So first we have to get the time period. What is the time period here? That is -1 to 1 and time period t equal to 2. And omega is 2 pi divided by t, that is 2 pi by 2 is equal to pi. So let us choose the interval from -1 to 1. So we have two parts, -1 to 0 and 0 to 1. So we have to find out the equation for the signal from -1 to 0 first. So -1 to 0, take 2 points, x1, y1 is 0, 1 and x2, y2 is -1, 0. So this is x1, y1, 0, 1 and x2, y2 that is -1, 0. So substituting these values, y minus 1 divided by 0 minus 1, and we'll be getting this equation as y equal to x plus 1. So here in this case y is x of t and the x is t. So our equation is x of t equal to t plus 1. Similarly, from 0 to 1, x1, y1 is 0, 1 and x2, y2 is 1, 0. So substituting and simplifying, we will be getting the equation as x of t equal to 1 minus t. Now our aim is to find the exponential Fourier series. And we have the equation x of t equal to sigma n equal to minus infinity to infinity Cn e raised to minus jn omega 0 t. And we have to find the coefficient Cn. So Cn equal to 1 by t integral x of t e raised to minus jn omega 0 t dt. So the integral is from -1 to 1. And we have the time period is equal to 2 and omega 0 equal to pi. So substituting omega 0 as pi and time period equal to 2. And the integral is -1 to 1. So we are splitting that, -1 to 0 and 0 to 1. So the equation we have -1 to 0 as 1 plus t and 0 to 1 as 1 minus t. And here we are splitting 1 into e raised to minus jn omega 0 t is the first term and t into e raised to minus jn omega 0 t jn pi t is the second term. And similarly here 1 into e raised to minus jn pi t and second term minus integral t e raised to minus jn pi t. So we have 4 terms. So for simplifying, we are calculating each term independently and we will be substituting these in the equation. So first a is equal to integral -1 to 0 e raised to minus jn pi t dt. So integrating e raised to minus jn pi t divided by minus jn pi and applying the limits -1 to 0. So e raised to 0 minus e raised to jn pi divided by minus jn pi. So we will be getting what is e raised to 0, that is 1 and 1 minus e raised to jn pi divided by minus jn pi, that is 1 by jn pi into e raised to jn pi minus 1. So this is A, equation 1. Now the second term b equal to integral -1 to 0 t e raised to minus jn pi t dt. And you may be remembering the relation integral x e raised to ax dx equal to e raised to ax into x by a minus 1 by a square. So what is x in x here? That is x equal to t. And what is a? A is this jn pi minus jn pi. So that is a. So x is t and a is minus jn pi. So our equation becomes x e raised to ax is e raised to ax. So first term is e raised to ax, that is e raised to minus jn pi t into x by a. X by a is t by minus jn pi minus 1 by a square, that is 1 by minus jn pi the whole square. And the limit is from -1 to 0. So applying the first limit 0, e raised to 0, first term will be 0 minus 1 by minus j n pi the whole square. So what is j square? J square equal to minus 1. And what is minus square? That is plus 1. So we'll be getting minus of n pi the whole square. And second limit minus of e raised to j n pi into second limit is minus 1. So substituting minus 1 for t, minus 1 divided by minus j n pi minus 1 by minus of n pi the whole square. So we'll be taking these terms 1 by n pi square together. So 1 by n pi square, first term is 1 by n pi square minus e raised to j n pi into 1 by j n pi minus e raised to j n pi into 1 by n pi the whole square. So 1 by n pi the whole square into, first in here 1 and here minus j n pi, e raised to j n pi. So 1 by n pi square into 1 minus e raised to j n pi minus this term e raised to j n pi into 1 by j n pi. This is the second term. So that is the expression for B. So we have got A and B. And the third term C is integral 0 to 1 e raised to minus j n pi t dt. So integrating e raised to minus j n pi t divided by minus j n pi, and the limit is from 0 to 1. So minus 1 by j n pi into e raised to minus j n pi minus e raised to 0. So that is 1 by j n pi into 1 minus e raised to minus j n pi. So that is the expression for C. Now D equal to integral 0 to 1 t e raised to minus j n pi t dt. So that is equal to e raised to minus j n pi t into t by minus j n pi. We are applying this relation. X e raised to ax dx equal to e raised to ax into x by a in minus 1 by a square. So here x is t and a is minus j n pi. So t divided by minus j n pi minus 1 by a square. So that is equal to 1 by minus j n pi the whole square, and the limit is from 0 to 1. So as earlier we are substituting these values. So we will be getting the term just before the last case, 1 by n pi the whole square into e raised to minus j n pi minus 1 minus 1 by j n pi into e raised to minus j n pi. The expression for substituting the values 1, 2, 3 and 4 in the equation for Cn. 1 by 2 into first term is 1 by j n pi into e raised to j n pi minus 1, and second is 1 by n pi the whole square into 1 minus e raised to j n pi minus 1 by j n pi e raised to j n pi. And the next term is 1 by j n pi into 1 minus e raised to minus j n pi minus 1 by n pi the whole square into e raised to minus j n pi minus 1 plus 1 by j n pi into e raised to minus j n pi. So taking these two terms together, we will be getting 1 by j n pi into e raised to j n pi minus 1 plus 1 minus e raised to minus j n pi plus 1 by n pi square. These two terms together. So 1 by n pi the whole square into 1 minus e raised to j n pi minus, the minus is here. So minus e raised to minus j n pi plus 1, minus minus plus 1. And these two terms together, minus 1 by j n pi into e raised to j n pi minus e raised to minus j n pi. So here a minus is taken outside, minus 1 by j n pi into e raised to j n pi. So here this is plus, so as we are taking minus outside, we will be having a minus here, minus into minus plus. So e raised to minus j n pi. So the equation becomes 1 by 2 into 1 by j n pi into e raised to j n pi minus e raised to minus j n pi plus 1 by n pi the whole square into 2 minus these two, 1 plus 1, 2, minus of e raised to jn pi plus e raised to minus jn pi. And third term is minus 1 by jn pi into e raised to jn pi minus e raised to minus jn pi. Now we have the relation sin x equal to e raised to jx minus e raised to minus jx by 2j, and cos x equal to e raised to jx plus e raised to minus jx by 2. So we are substituting these for e raised to jn pi minus e raised to minus jn pi and e raised to jn pi plus e raised to minus jn pi. So here we are giving those values, 1 by jn pi into 2j sin n pi plus 1 by n pi the whole square into 2 minus 2 cos n pi minus 1 by jn pi 2j sin n pi. These terms cancels. So we are getting 1 by 2 into second term, that is 1 by 2 by n pi the whole square. This 2 is taken outside into 1 minus cos n pi. So what is cos n pi? That we know, that is minus 1 all raised to n, and these 2 is cut. So 1 by n pi the whole square into 1 minus minus 1 all raised to n, and that is equal to 1 minus, so here for n is odd we will be getting this as 2. So 2 by n pi the whole square for n is odd, and this will be 0 for n is even. Now we have to calculate C0. So that is 1 by t integral t0 to t0 plus t x of t dt. So we know that C0 is nothing but A0. We know the expression for A0, that is the average value 1 by t integral xt dt. So here in this case, what is xt? Xt is minus 1 to 0, 1 plus t, and 0 to 1, 1 minus t. So integrating 1 plus t is t plus t square by 2 minus 1 to 0, and 1 minus t is t minus t square by 2, 0 to 1. And applying the limits and substituting the values, we will be getting C0 as 1 by 2. So we have Cn equal to 1 by 2 for n equal to 0, and 2 by n pi the whole square for n is odd, and 0 for n even. And the angle of 0, so this in here, this is not imaginary, so we have the angle 0 for all the cases. So for all values of n, angle Cn is 0. Now we have to plot the magnitude spectra and phase spectra. For that purpose, we have to calculate the magnitude for different values of Cn. And the angle or phase of Cn, we know that it is 0 for all case. So we have to calculate, we have the equation C0 equal to 1 by 2. So that is C0 equal to 1 by 2.5. And we have to calculate for C1, that is 2 by n pi the whole square, n equal to 1, 2 by pi square, that is 0.2. So for minus 1 also we will be getting 2 by n pi square, that is 0.2. And for n equal to 2 it is 0, and n equal to 3, that is 2 by n pi the whole square, that is 2 by 9 pi square is equal to 0.02. And for 4 it is 0, and for 5 it will be 0.008. Now we can plot the magnitude spectra. So at 0 we have 0.5, and at 1, 2 by pi square, that is 0.2, 0.2 for plus 1 and minus 1. And for 3 it is 0.02, 2 by 9 pi square, 0.02. So that is for 3 and minus 3. Similarly for 5 it is 0.008, and minus 5 also 0.008. And this is our magnitude spectra. And this is our phase spectra. Angle, the phase of Cn versus n. So here it is n. So this is magnitude spectra. This is these values are 0 for all n. So here for 2, 4 and minus 2 minus 4 it is 0.